I'm very pleased to introduce Patrick Lucey. He is the chief scientist at Stats Perform, which is a company that uses data to elevate the experience of sports fans. His main research interests are in artificial intelligence and interactive machine learning in sporting domains. Previously, Patrick was at Disney Research for 5 years, where he conducted research into automatic sports broadcasting using large amounts of spatio-temporal tracking data. Before that, he was a postdoctoral researcher at the Robotics Institute at Carnegie Mellon University and the Department of Psychology at the University of Pittsburgh. He's conducted research on automatic facial recognition, and he has papers in the research track, or the final of the research track, at the MIT Sloan Sports Analytics Conference in 8 of the last 9 years. He won this in 2016 and was runner-up in 2017, 2018. So he has a foot in the research field and in the industry of data science. His goal is to maximize the value that 40-plus years of sports data experience that Stats Perform has, and he's going to be talking to you tonight about how that happens. So it's my pleasure to introduce and turn it over to you, Patrick.
Great, thanks, Andy. I appreciate the kind invitation, the kind words. So, as mentioned, my name is Patrick. I'm Chief Scientist at Stats Perform. I'll get out of the light there. Just talk about some of the work that we're doing in sports. So, thanks for coming. Hopefully you find it very interesting. So, my background, as Ken mentioned, of background in electrical engineering. So, basically dealing with a lot of unstructured data. I did my undergraduate thesis, honours thesis 20 years ago now on face recognition. And then I worked at IBM as an intern in part of my PhD, where I was recognised in visual speech regardless of head position. Afterwards, I was fortunate enough to work at the Robotics Institute, where I worked with Ian Matthews. So what you're seeing there is an active appearance model. And so we're using that to measure human behaviour. So we're using that to measure pain, depression, and facial paralysis. But the same technique there, was actually used for Avatar. So I worked with Ian. He actually won a technical Oscar for that. So what they did, track actor's face, and then we projected to animated character's face. So it's kind of cool, just measuring unstructured data via computer vision and machine learning. And then I got the great opportunity to work at Disney Research, and I worked on a couple of things there. So first of all, we were watching people watch movies, and so I can't show you an actual audience, but based on facial expressions and body motion, we're able to actually find which parts of the movie people are actually interested in. So there's an excellent book by Walter Murch. He was the editor for Apocalypse Now, and he used to look at the synchrony of blinks. And so it's not what actions they're doing, it's if people are doing something at exactly the same time. Doing nothing is something. And so we actually have the pattern on that, and cool stories I can tell you later, but we were watching people watch movies, and we saw lots of interesting behaviours during that. But the main reason why I worked at Disney Research was to work on an automatic sports broadcast. So probably asking why are Disney interested in that? Well, Disney owns ESPN, and what we're finding now, people cut the cord. So once upon a time, ESPN brought in 40% of Disney's revenue. So back in 2010, because at any one point in time, most people in the US had cable. And so for every subscription, ESPN would get $6 of that cable subscription, even though a lot of people didn't watch it. So now people have cut the cord. Very few people have cable. The only reason why you have cable is to watch sport, because you don't want that buffering. And so 10 years ago, I started working at Disney 10 years ago. We saw this, and we were trying to do an automatic sports broadcast by having a smart venue where we'd have cameras fixed up, we'd track players in real time, and we'd move a robotic camera. So my job was to teach a computer sport via tracking data. And ESPN didn't actually have tracking data, so that's why I worked with Stats. So I collaborated with Stats and Prozone, and did some nice research there with my colleague Peter Carr, but actually came to Stats, or Stats Perform now, because they have all the data. And you're probably asking, so over the last 10 years I've done a lot of work, I'll touch on that today. But the big reason why I work at Stats Perform is because they have a lot of data, and a lot of the work has been chronicled in various forms. I see we have Chrissy, who's written an excellent book on this stuff as well. But the reason why I work at Stats Perform is because we have all the data. And who here has actually heard of Stats Perform? It's okay if you haven't. But if you haven't and you follow sport, you probably touch us every day. Okay, so there's international games happening, or just say you Google a score, you want to know the score. Where do you think Google get their data from? They get it from us. Or if you ask Amazon Alexa or Apple Siri a sports question, where do you think they get their data from? They get it from us. So it's kind of cool, people don't know it, but billions of people touch us every day. So whether it's media or whether it's in broadcast, so one of our brands is Opta. So Opta Joe, we have over 2 million people follow us. A lot of the things that you see on broadcast, so Sky Sports show expected goal value. We came up with expected goal value 10 years ago. More recently, Oracle sponsored something called Momentum, and that's generated by us live. Live win probability, which is shown on Amazon Prime, we created that. And more recently, we're doing season simulation, but that's just scratching the surface of what we do. So when you see stuff like that, that's created by us, because you need the data to drive all of that. And so it's really interesting. So again, grateful to get the kind invitation to speak here, because really what we do with sports data is measuring human behaviour, and that's at the core of a lot of interesting things. But just to get everyone up to speed on the history of sports analytics, I like to think of it in two eras. Number one is the data-driven era, and Stats Perform, we've been around for over 40 years, and the godfather of sports analytics is this guy. His name is Bill James, and so he actually helped form Stats Inc. back in 1981. He was part of a group called Project Scoresheet, and they wanted more baseball data. So they wanted more granular baseball data to come up with better metrics. So out of that group, John DeWine set up Stats Inc. in 1981. And then from there, the business evolved, and then we have Daryl Morey, who's the godfather of basketball analytics. He actually started his career at Stats back in the 1990s. And a lot of his basketball analytics came from that initial work, because you need data to do this type of stuff. And so since then, I call this the data-driven era, because this is where data in sport, was started to be generated at scale. And a lot of people think that soccer is, I'll call it soccer just to avoid confusion between American football, but people think soccer is far behind the US sports. That's actually not the case. Tracking data has actually been available in soccer for over 20 years. So one of the companies, which is owned by Stats Perform, or we acquired, Prozone and Amisco, they started doing that over 20 years ago. So now on TV, you're thinking, well, tracking data is a new thing. It's actually not. Been collecting that for quite a period of time. Opta actually started collecting the live XY data back in 2005, and Running Ball, which is our betting feed, that actually started to be collected in 2006. And all sports books in the world use this for soccer. So every game we cover over 100,000 games a year. We have scouts in venue collecting that data. But something happened around 2010. So this is where we had a computer vision generated tracking system with our SportView system. So this went in the NBA in 2010, where we had 4 NBA teams, and then it went NBA-wide in 2013. And I call this era the AI-driven era. It's the start of the AI-driven era, because we got an AI system, a computer vision system, to start generating this data. And it's been scaled across different sports such as basketball, soccer, tennis. Actually, tennis and cricket, they actually had a tracking system back in 2005, which could do this. But I call this era the AI-driven era because the data-driven era with Moneyball was so successful. People wanted more granular data, and so we had to look at forms of how to collect that. And having humans to do that isn't really scalable. So we had to use computer vision systems to do that, but that created unstructured data. So we used machine learning to actually find some sense of that data and find representations where we can do some interesting analysis. And so that's really what the talk today is about. How can we use these unstructured data sources to generate some interesting analysis? And really, it's an interesting test bed. I think it's one of the most interesting areas in machine learning, because you think of the data is multi-agent, it's adversarial, and it's fine-grained. I actually gave a keynote at DeepMind, because they're doing work in this space now. They're partnered up with Liverpool, and they're doing some interesting work in this space because the data is so rich and interesting. And so in terms of the types of sports data available, I think it's important to kind of let people know what types of data are available and how to think about it. But first of all, what is the value of sports data? The way that I like to think about sports data, given that I'm electrical engineer as a background, is in terms of reconstruction or compression. So basically, sports data reconstructs the story of the match, and the more granular the data that you have, the better the story that you can reconstruct. So let's just use an example. Let's just say there's a game being played. Liverpool are playing Leeds, and I have a 2-year-old now. I used to watch all the games, but now I just have no time. So instead of watching a game for 90 plus minutes, within 5 seconds, if I just look at the box score, so if I go to Google, pull it up, I can see that this example was taken from last year. Leeds drew with Liverpool 1-1. So instead of watching the game for 90 plus minutes, within 5 seconds, I can reconstruct the game. You know, it's not a great reconstruction, but it is some type of reconstruction there. I can see that Leeds drew with Liverpool. Liverpool scored the first half, and then Lorente got the equaliser late. And so again, you know, it's not perfect, but it's a reasonable reconstruction. And then I can look more in the detailed box score, where I can say, well, Liverpool had more shots. Surprisingly, Liverpool had less possession than Leeds. And within another 5 seconds, I can have a better reconstruction of the match. Again, I don't have to watch a game for 90 plus minutes, but you know, that's the value of the box score. Now, if I wanted more detailed information, I could look at the play-by-play. And you can think of play-by-play as a description of each possession. So basically, I want to know each possession and what happened at the end of the possession. So we could have scouts actually log that, or we could actually do that automatically via a collection system. And so that gives us more of a description of what happens during a match. We can also use our spatial data. So this is what we do, where we have humans actually generating this data. They log this data. So here we have the replay of a goal being scored. And so here with our event data, we're actually getting the position of all the events in that leader. Also, we have our fast data, where this is used for betting, where we have scouts in venue, where they're logging this information in real time, because for sports books, they need this because they're supplying this to create betting markets. But really, over the last 10 years, I've focused predominantly on tracking data. So tracking data is the best reconstruction of the video. So the best information source is actually video. Video is king, but that's an unstructured data source. So you can see it's very rich in pixels. What we have there with our tracking data is actually reconstructing what we have in the pixel set. And I'll talk more about that, but it's basically a 1,000,000-to-1 compression. People think tracking data is big data. It's not. It's actually quite small. The problem is with permutation. But video is big. Tracking data is relatively small. But you have to find ways of representing that, and I'll talk about that a bit shortly. But just in terms of summary, in terms of the data that we have box score, we have event data, and then we have tracking data, and that's really generated by video. And for this talk, I'll be talking mostly about what we can do with tracking data. And I call this primary data. At Stats Perform, we're the keeper of public record. So when a game is played in the public sphere, we collect that. And this is the type of data that we collect for those events. There are other forms of data, such as social data and also market data, where that reconstructs or it summarizes some parts of the play, but I call this secondary because you can't explicitly reconstruct what happened every event from this data. You have to do some data parsing to kind of tease that out. But that is a useful form of data, but in terms of the group that I run, we don't really focus on that per se. Now, there's another form of data, private data, that we don't touch either. So if you think of each club, and this is really their own IP, where you have contracts, you have medical data, you have psychological data, you have wearable data. We don't really deal with that because it's very hard from an AI perspective to scale this out, because each team will collect it in different ways. There's GDPR, it's very hard to create scalable prediction systems using this data because there's so many sensitivities around it, and essentially you have a lot of holes in your data ecosystem. So in terms of what we focus on at Stats Perform, it's really around the public data, and today I'll be talking about the more unstructured data sources here. Now, in terms of applications of what we can do with it, There's a lot of discussion out there looking at the full automation of data collection using computer vision systems. However, I don't think that's the future. You think of doing full automation of all the data collection, like every pass, every shot. That's not a really good use of resources. So really the future of data collection is using the human, so our scouts that we have, plus our computer vision system to augment that. However, that is still unstructured. And so what we do as a first layer is from the event feed that we have, which is generated by humans, we couple that with our computer vision system, and then we can map that to a semantic layer, such as playing styles in soccer, or different events in basketball, such as pick and rolls and off-ball screens. We can map that to a semantic layer or come up with some quality metrics there. Now that really forms the basis of our analysis and our data footprint. However, in terms of applications, this really drives two dimensions of applications. The first one is precision and the second is scale. And so for the last 10 or 15 years, a lot of the applications that have been driven by computer vision systems has been around these two applications. So first one is around officiating, where you actually, so it's used widely in tennis, where we can track the ball, and it's used for umpiring decisions. And more recently, for soccer, there's a big problem with VAR. It just takes too long. And so you're looking at data providers where they're actually tracking the pose and seeing where the shirt sleeve is, where they can make decisions very, very quickly. Now, people thought with a few cameras you could do this quite accurately. That's actually not the case. To actually do this, and it's not really scalable, you need about 20 or 30 cameras to get the pixel density there. So in terms of applications, it's not really scalable. And that's also with our broadcast solution. So there's a company called Second Spectrum, run by a genius. They're able to do this augmented view, where they can superimpose animations and semantics underneath to lead to a more interactive consumption of the video. Then also you have Intel, who have their 38 camera system within NFL arenas, where they can do some really nice reconstruction views, like matrix type of reconstructions there. Now, as I said, these are really nice applications, but for a company like us, we focus on scale. We want to cover every game that's ever been played, currently and going back in time. And to do this, you need a lot of hardware, you need rights, you need humans in the loop, which makes this very, very difficult. So on the flip side, when you look at scalable applications, and I'll talk about this quite a bit, the second part of the talk around interaction. So there are things that we can do to lead to more interactive applications, because sport has a very we have a language of X's and O's, so we really want to facilitate that type of interaction. And then also there's predictions as well. But that can also power other applications on top, such as highlights and insights. There are a lot of companies that use the event feeds and then predictions on top as relevance measures, where we can generate highlights and insights. But also, as we're going to more OTT, this can be used for relevance measures such as dynamic advertising and whatnot. So in terms of the overview, I'm just going to go over how we can create and utilize tracking data, an insight into interactive applications, and then I'll quickly go through what we do in terms of predictions and insights, and then finish with what I think are future research and key challenges and some of the things that we're working on at Stats Perform. So really, I'll get started with talking about how we can create and utilize tracking data. Now again, I keep talking about reconstructing the story of a match. So what does that actually mean? So here I'll just have an example of our Sport View system when we had the NBA deal. And this is when the Portland Trail Blazers played the Golden State Warriors. So really what we want to do is, from the raw pixels, we actually want to map that story. So you can think of it in terms of a book. So everything's about representation here. So, and before we do that, we have to come up with the right structure. And so a lot of the analysis that we do in sport, we have to come up with the right unit of analysis. And a lot of the times it's around a possession. Or in basketball, we have a sub-possession called a chance. And it really maps to how many points that can be scored during those possessions. So it could be 0, 1, 2, 3, or 4. Probably asking in basketball, how do you get 4 points from a possession? Well, you make a 3-point shot and you have the foul shot as well. And then that is rolled up into a lineup. So you have consecutive possessions where the same players are on the court. And then again, you can map this, you can aggregate this up into a match view. So we call this a bottom-up representation, and this allows us to reconstruct that story. And so why that's important is that we can come up with this right structure. So if you have this book analogy, we can represent each possession as a page. And in terms of what we want to document on each page for that possession, first of all, we can talk about what happened, which is really the possession outcome. Then we really want to know how it happened. You know, it's given a bit more color there. And also how well it was executed. Now, if you think about the data which is collected in the most part is, you know, we have this play. I'll just run through. We see it's a pick and roll here. It's a drive to the basket. It's a push out. It's a drop pass. There's an off-ball screen there. It's a missed three-point attempt, and there's a defensive rebound. And so for the longest time, the data that we had was collected by a human, and we're able to say, well, you know, so the human in the loop couldn't capture all that rich information. So all they would give you is what happened at the end of the possession, right? Now, how it happened, you know, the pick and roll, the drive, the off-ball screen, the drop pass, we don't have any documentation of that. In terms of how well it was executed, you know, what was the shot difficulty or what was the possession value behind that, we don't really know. And so this is really why we need a computer vision system to do that. Because humans, even if we got humans to do that, they're not accurate enough. They're not going to get the precision of each player location. They're not going to get the precision of when these events occurred. And these events have durations. You need to know the onset and the offset. Also, you need to know the defensive coverages as well. And so really to do this via computer vision, we start with a video, and then we map it to these dots or trajectories as you saw there. And then we can map it to a semantic layer, which again is compressing the data, and then we can describe how well those plays were executed. So these are the steps, and I'll quickly step you through how we actually do that. And so once we have this representation, we can start to fill in the gaps and tell a full story. Okay? And so again, people always talk about tracking data as the latest innovation in sport, but again, it's been around for quite a period of time. And so you have to think about what the tracking data gives us. So again, dealing with the raw pixels here is tricky. We can perceive it really well. However, to get a computer to understand it, it's quite tricky. So if you think about what we have from an in-venue tracking system, for each frame, and we collect at 25 frames per second, that's around 300 megabytes, right? So that's a lot of information. Now, when you think about what we get from the tracking data, so we're mapping this to 10 players, their XY location, and also the XYZ of the ball. That's basically 29 values, so about 232 bytes. Now, if you think about that compression ratio, it's about 1,000,000 to 1. So basically what tracking data is the H.264 compression of video, right? So it's not big, it's actually compressing what we see there, but it is unstructured. So we have to do things to actually understand that. But that's really the value of tracking data. It's just compressing what we see in the video and gets it in a form where we can start to utilize it. And so we'll talk about that more later, where we can deal with the trajectories. So once we have this lower dimensional representation of what we have for the pixels, we can start to map some semantics. And what I mean by semantics, and again, I'll start with basketball, is, especially in basketball, there's a well-formed language behind how you can describe a game. And really, you can view the tracking data here, and this is from an AutoStat system. But really what we want to do is map it to some words where we can describe what's happened. So there are two phases to this. We can better describe the outcome. So from the play-by-play, we can say, oh, a shot occurred, an off-ball, offensive rebound or a defensive rebound or a block shot occurred. With tracking data, we can get precise locations and timing. But also, we can have a better description of what led to the basket. And again, in basketball, over the last 10 years, it's a very well-formed language, such as there's a pass, a dribble, a possession, a post-up occurred, an isolation, a drive, a ball screen or a handoff. There's an off-ball screen. Those are the events. Also, we want to know which player's guarding who, what type of defensive coverages are there. So it's quite rich. And having that tracking data to start with enables us to detect those things in a supervised learning context. And so that's really what we do. And also we can measure the defensive matchups as well. So again, we're just kind of mapping this information so we can actually utilize it for analysis later. So once we have those semantics, that's a language. So NBA teams tend to do this, and our college teams are using this as well because they have an upcoming opponent. They want to describe a player based on their pick and roll performance, or how often a team runs off-ball screens, or in certain situations, which players are strong against certain types of pick and roll coverages. So that's really a language that domain experts use, and we're able to facilitate that by accurate detection of those things. But then also we have quality metrics, can measure how well a certain action was performed. And what I mean by that is, so just say we have a shot, and when we have a label associated with a shot, it could be unsuccessful or successful. So we label that as 0 or a 1. And so instead of having a 0, 1, we basically want to map it somewhere on the spectrum, right? So we can use supervised learning just to map that function and just see where it lies on that spectrum there. So again, I'll use this example where we have the drive into the basket. And so what we can do is look at all the historical shots like this, and then we can say, well, he missed it, but really the effective field goal percentage is 22%. And it's similar to what we do with expected goal value in soccer. So instead of a shot being successful or unsuccessful, we want to know where it is on that spectrum. And this is where we can use machine learning to actually find that probability. It's similar, so this is what Luke Bourne and the team have done in basketball. We have a similar approach in soccer where we can actually map the expected point value. So it's not only knowing how well a shot is executed, we want to know how each action within a possession is executed. And so these are other metrics that we can create, or essentially we're creating the thermometer to measure performances and behavior. And what we can also do, as I mentioned before, this hasn't pulled up there, so we had a player report of a college player. So instead of knowing how well they shot, we could break them down into post-ups and isolations and whatnot, which we partner with the Orlando Magic, and they use that to make drafting decisions. And so if we kind of pivot to soccer, it's a similar story here. So we have a lot of the events already for soccer, so we call that semantics. But what we want to do is actually start mapping some team level information, because we have the passes, we have the shots, but also what we want to know is how is the team executing certain styles during the game. So this is what we do for soccer. So first of all, we have to map a game into in play versus not in play. So if a lot of you probably don't know, a game of soccer, the ball's in play basically half the time. So after 90 minutes, about 45 minutes, the game's actually in play. So Frost might talk about some of these quality metrics such as expected goal value. This is 10 years ago. This stuff was created 10 years ago. Last week we created a new XG 2.0 model where we just had more data points. And we generate that live. And so for something like expected goal value, it's what the average player, given the context around that shot, what's the likelihood of the average player scoring that situation. So obviously if Messi and Ronaldo in those situations, they're going to execute, they're going to score more in those situations. So their average expected goal value is a lot higher. However, in those situations, you have a Messi and Ronaldo, they're going to take a lot more shots than the average player would do. And I really think this is the next frontier of sports analytics. We've got to start measuring what didn't happen. And a pet peeve of mine is you're watching a lot of players expect, especially around passing, they'll pass sideways and their pass completion rates will be high, but they're not really taking the aggressive pass. Yeah. So I think, and using reinforcement learning techniques where we can start to simulate other situations, I'll talk about some of our work that we've done with imitation learning. But again, it's around counterfactual analysis. So in this situation, could be, well, in that situation, would he shoot or would he actually pass? You can start to ask those what-if questions, which is quite interesting. So essentially, within a supervised learning paradigm, you can do expected goal value, you can do expected pass value in each situation. You know, how often does the average player make that pass? We have something called expected possession value, which measuring performances of strikers and goalkeepers. Now we can actually start to measure the actions of each of the players. And so this is kind of a view on how we can actually come up with those descriptions of each player. But more recently, we had a paper last year at Sloan, which was looking at measuring off-the-ball events, you know, active runs, the type of defense, because again, we want to measure what didn't happen. We want to see, you know, a step that Virgil van Dijk did, you know, that'll stop an action. So can we start to measure those type of things? And so those are the types of things that we can do. So with more information, so with more tracking data, we can actually do better analysis. Now, the problem is that the coverage of tracking data isn't there. And so to do the best analysis, you want very rich data, and if any researchers are here, you want to get in the space. You know, there's not a lot of tracking data available. You say, well, I want to do this, but it's hard to come by. And it's really to do with the coverage. So for the longest period of time, the best way of collecting tracking data in sport is via in-venue solution. So we have a SportView system, which came out 10 years ago. More recently, we have our SportView 2.0 system, which is the premier mobile solution. We have this in the French League and the Belgium League, where we have a gaming machine, we have 3 4K cameras, and we're actually detecting players and tracking them in real time. However, to do this, you need to be in venue. And another problem is that even if you start collecting tracking data now, how do you go back in time? And so this is, you know, leads to a coverage problem. So you want to make decisions. To make decisions, you need to have data. You don't want holes in your data. And so even though tracking data is the best source of data out there, you can't really use it, especially for a game like football, because you don't cover every league. And so even though tracking data does exist in most top leagues, they're via different providers. So Liverpool, so just say Liverpool, they want to have tracking data against upcoming Champions League opponent. They don't have access to the tracking data in Italy, or they don't have the access to the tracking data in the French league. So it leaves a big gap. Now, more recently, the last 2 or 3 years, or 3 years, we've been focusing on how we can actually capture that from broadcast. And so we started in college basketball. So in Michael Lewis's book, The Undoing Project, I think the first chapter talks to Daryl Morey. You know, they want to have more data to actually analyze upcoming draft players or international players, but that data really doesn't exist. So what we've been able to do is, from broadcast, we go back about 10 years. We've collected nearly 10,000 games worth of college basketball now. We've partnered with the Orlando Magic. And to do this, we've had a couple of breakthroughs in terms of computer vision. The first one is to calibrate a moving camera. So an in-venue solution is where you only have to calibrate the camera once. You have fixed cameras, you calibrate the camera once. Here, especially for a US broadcast, it could be 30 or 60 frames per second. So we have to calibrate at that rate. And so that's tricky. But also, players come in and out of view. And so what we actually do is use body pose technology. So we use open pose through a partnership with CMU. We're able to track the pose of players, which is very, very important to do re-identification. And so based on those two things, we're able to identify players, collect this tracking data, which enables us to come up with that enriched data downstream. And so we're actually doing this for soccer. We're actually doing this live as well. And so in the next year or so, you'll see, you know, this data becoming available, because this is really the future of soccer data, right? We've been leaders collecting Opta data, but the real future of this is human plus computer. So for every pass, you need to know where all the players are. You can get humans to do it, but they're just not going to be accurate. So having computer vision aided collection is really what we've been doing, and we've been focusing on this for the last 3 or 4 years. And we're at a good stage now where hopefully this will become widespread. But really what this unlocks is not only coming up with better metrics of players, but it also leads to better applications. And so I've talked about reconstructing the story of the book, compressing what we see and reconstructing the story of a book. However, you know, this is 2022. Most people don't read books, or they prefer to read it on an iPad or play an Xbox. So how can we use the tracking data to really unlock these type of applications? And so that's really the next thing that I'm going to talk about. How can we do things that humans can't do? And why do we need interactive analysis? And so there are some things that humans can't do very well. So in terms of strategy analysis, in terms of formation analysis, the best technology out there is Pep Guardiola. So if you watch All or Nothing with him, he's a genius on the magnet set. However, that still represents the best way of analysing strategy. In terms of search, if anyone is familiar with this, search in sport is terrible. It's very manual. I'm showing sports code here, and it's still a very manual endeavour. And then also simulation. So most people in the US know soccer from playing FIFA. However, we don't use it to analyse. So having this type of interactive application is quite useful, and using tracking data and some of the things that we've come up with, we really unlock that value. So what do I mean in terms of strategy analysis? So I played 8 years semi-pro soccer. I used to do a bit of coaching. A lot of the motivation, the work that we've done, comes from the lack of analytics. But he's the king, the former leagues manager now. But when they're in Division 1, he had this rant. He got caught spying, or one of his coaches got caught spying on Derby County. And the day afterwards, he had this brilliant 70-minute presentation talking about the analysis that he's done. So he basically said, well, when you're analysing a team, basically what you need to know is the starting 11, the formations, and what they do on set plays. And so to do this, yes, you have to do this, but to do this, it takes a lot of time. And for leads to do this, they actually take about, I think it's about 200 hours. It's 5 hours for each game that they analyse. And he said, we watched 50 of Derby County's games, so 4 times 50, that's about 200 hours. So for every upcoming opponent, they'll spend about 200 hours just cutting tape and analysing that. And so here's a snapshot of the formation analysis that they do. So they'll break down each 5 minutes, and they'll say, well, this is the formation, and this is the player involved, and they'll break this up. And so even though that's good, it's not very efficient, and it's actually not very accurate. And if you watch Monday Night Football, and this was taken a couple of years ago, the best form of analysis is still qualitative. So you'll have Jamie Carragher and Gary Neville, and they're analysing Benjamin Mendy coming into the team, replacing Fabian Delph, and just seeing how that change of shape happened. So that's really good, but it's not quantitative. So how can we actually start to do that quantitative analysis? There's some really nice stuff out there. So if you go to The Athletic, Michael Cox has written some nice books. So he had zonal marking about 10 years ago, and now he writes a lot of that stuff for The Athletic. And if you use our Opta data, so just say you find the average players, so that's great at the start of the match, but if you actually see their average touch positions, you'll basically just see a big ball of yarn there, so you'll just see a mess. And so it begs the question, so how can we actually measure that? Well, it turns out tracking data is messy, right? It's noisy. So if we just plot the positions of every player and each colour is associated with each player, we can see that players are on top of each other. That makes sense because players switch positions during the match. Now, what we actually want to do is actually untangle that. And so for the last 10 years, this is really what we've been focusing on, how we can untangle this graph. And it turns out that the permutation is the major issue here. So I've written many, many papers here. You can go to my website, we can find that out, but that's basically the crux of it. And actually, we have a product which focuses on measuring shape, but that basically gives you the intuition on how that happens. But I have limited time, so I just might jump ahead to the next thing. So I might talk about search. And so the big question is, how can we actually do search in sport? And so I was motivated by a quote from Merrill Hodge. He was an ESPN analyst, and he was saying one day, I watched 29 hours of video to find similar plays. So he was analysing the Houston Texans running game. He was very proud. So I watched 29 hours of video to find a similar play. And for me, that seemed very, very inefficient. And so when we actually search in sport, you can think about a spectrum. It can be very coarse, you can use semantics, which we've described, or you can be very specific. Or you can have a hybrid approach. And so for the last 10, 20, 30 years, most people have used sports code, where that's basically what the analyst's job is, to actually code video. And what you can actually do is kind of do some spatial analysis there, or you can be specific. And so I'm going to use an example here about a specific play, and we've done this for basketball. So let's just say we have this play, and the question is, well, how can I search that play? I want to find all the plays exactly like that. So how can I go about searching that play? Well, I could use words, semantics, I could type that in. I could say it's a three-point shot, or I have a more expressive language, such as it's a pick and roll, it's a behind-the-back pass. But if I want to find the play where all the players are in that same position and the velocity and acceleration are the same, how many words would I need to use to describe that? And it really begs the question, what's the right language to use in sport? And so, is words actually the right language to use? So actually, I don't think so. So we actually, again, you have to think about what the tracking data is. It's reconstructing what we see here. So instead of using words, can we actually use the tracking data? And that's what we've created. We've created a visual-based language. Like coaches, they have the X's and O's. They can draw a player up. And then based on that visual input, we can search our database. And instead of 29 hours, we can actually find a play less than a second. So we call this chalkboarding, where we have an interactive interface. We've done the same for soccer here. But the idea is that we see the tracking data here, and tracking data is, again, reconstructing what we see in the video. So we're just showing the tracking data. We can pull that up. Red is the ball here, yellow is going left to right, and green is going right to left. We can select how long the play is, so we can say it's 3 seconds long. We can get to the point of the match which is interesting. We can scrub through, and then once we actually get there, we can say, well, let's stop the play there. Let's find all the plays exactly like that. And instead of 29 hours, we can find a ranked list of all those plays. We can also make this interactive, where we can get the user to select which players are important. So a big thing is feature selection here, or weighting which players are important. So we can actually get the user to select that, or we could actually draw a play up. So can we draw a play up and find all the plays like that? And so I've talked a little bit about counterfactual analysis, and I actually think that's one of the most interesting things. So imagine we draw that play, or we find an example where we run that play, and you can think of it in terms of an educational tool, where you can say, well, what's the likelihood of this player scoring this position? What happens if I move that player around? How does his expected point value change there? What happens if I move the defender? Or what happens if I put another player in that situation? How do those percentages change? And so, again, having an interactive interface allows us to do those type of things. And I'm running short of time. The last thing I'll show is around, we have this actually in a product in Edge where we can actually do this, but I'll talk about the things that we've done in imitation learning, where we can do more counterfactual analysis. It's really motivated by, in terms of interactive experience of sport, you go to a sports book, or if you go to the NFL, they'll have a tablet, and I'll just pull up video. But, when you're playing a video game, you can play Madden or you can play FIFA, and that, represents really, really nice interactive experiences. The big question is, how can we actually generate those type of things? So a lot of work, especially Google, looking into reinforcement learning, and I think that works well if you are creating a video game, because it's you can control the actors, but in real world sport, you won't be able to control the players. So this is what we've done, motivated by Zach Lowe's article back in 2013, which chronicled what the Toronto Raptors did. And so they had a rule-based system, and they said, well, this is where we think the defenders should have been. So in our work, using our tracking data and using our role representation, we're able to actually simulate where the average English Premier League team, where they would have defended that, or you could use quality metrics like expected goal value to say, well, show me how a team should have defended this play to minimize the likelihood of them scoring. So red is the attacking team here, blue is the defensive team and yellow is the ball. What you're seeing in white is actually the ghost that we generate. Okay, so instead of predicting each player, we're able to predict the whole team using our representation there. And you can use that to do some interesting analysis, but what we've been able to do is actually do this on an interactive tablet. So John Madden was doing this 40 or 50 years ago, and Brad Stevens, when he was the coach of the Celtics, has a clipboard there, so it really doesn't represent any real innovation there. So what we're able to do is actually, first of all, create an interface where we could draw a play up, which is not trivial, to draw a play up and get all 5 players move at the same time. But then we can say, well, how did the Spurs defend a situation like that? So again, using tracking. Yeah, so in terms of what we're focusing on at Stats Perform, 3 main things is, number one, going back in time, and our goal is to create tracking data from every game that's ever been played. We're doing this for basketball, we're doing this for soccer, they're the first 2 sports that we're looking at, and really we're motivated by the goal of, well, can we go back and create data where we can start to simulate how Michael Jordan would play against LeBron James? So you go back in time, you can start to collect that data. So that's one of the things that we're looking at. The other thing is looking into reinforcement learning. So we've basically maxed out on, in my view, supervised learning. So we can predict, we can create these metrics. However, experts aren't very good at long-term predictions. So especially in a sport like soccer, where we have international competition. So just say I'm a manager, I have the Champions League coming up, I have international, I have a squad of 25. How do I manage those players? So using a reinforcement learning paradigm and working with a PhD student on this to solve this. So I think that is a big area that we're focusing on, and really where we want to get to is generating live assistant tools to help coaches and managers. And that's not really a machine learning challenge, it's more of it's a machine learning engineering challenge. So that's really what we're focusing on at Stats Perform with our live and scalable applications. So yeah, so that wraps it up. Happy to answer any questions. Thanks for your attention, and sorry I jumped around, so but I'll bring the dongle next time so I don't have to use the machine here. So appreciate the time, and yeah, happy to answer any questions. So thank you.
Thank you very much, Patrick. It's really interesting. One question I have, I was wondering how far into the future do the counterfactual analysis play, or the imitation game, because some of them are equivalent in correctly.
Yeah, so the way that we frame the imitation learning approach here is we have the attacking team and the ball, and we're actually predicting the defensive team. Okay. So we did that in a way, I don't think it's a cheat, it's just a more tractable problem, where the defensive team is reactive to the attacking team. And so it's a lower dimensional subspace. To actually predict what the offensive team would do, it's more of a Markov decision process where you have to map that game state, where you can do it locally, but it's very hard to predict even the next possession because it's very reactive. So that's why we've kind of constrained the problem. So the known knowns are the ball and the attacking team. How does the defense react there? We have done work, we had an ECCV paper in 2018 where we could simulate both, but you need a 4 to 8 second version of that initial query.
So who ultimately is your end customer? Is it betting firms? Is it broadcasters? Clubs?
All of the above, yeah. So again, we collect all this data. So what we do, we collect the data and these metrics, they can be used, and they're used by all those customers. So teams, media, so Sky Sports, ESPN customers, all sporting book use this information as well. And they use expected goal value, they use these metrics because especially with betting, they have parlays, they have player props, they want more engagement. So essentially we're creating these tools or these ingredients for our customers to utilize it. And the key thing is not only creating these metrics, but doing it live. And so a lot of the work that you'll see in sports analytics will be post-game. It's after the fact, but the utility of that's very limited. And so you have to be able to deal with noisy data, or and that means you have to simplify your models. So you have to be very pragmatic in how you can generate these outcomes, because if your model breaks or it gives a nonsensical answer one of the times, then you lose trust. So we have to facilitate that. Yeah.
I'm just interested in value generation. So you made I think, a pretty strong case that the data really is right now, you have all the data, you've collected it, labeled it to a large extent. I wonder, would you say that in the future more and more of that value is going to be generated in creating those, like moving up the stack and creating the semantics, the analysis, the what-if analysis? And then if so, could you see a future where most of the data is becoming open source, kind of free for anyone to kind of build their models on, and then you are primarily kind of providing those advanced insights?
Yeah, so the kernel of all knowledge is the data, so you have the video, but then you collect that data, and a lot of the data you need humans to do that. So that basically is the fuel. If you go up the stack and you figure out that foundation, you're basically going up and getting your legs chopped off. So AI is data plus models. If you follow Andrew Neat, MLOps, he created deep learning AI, and he was head of Google Brain, and you're probably familiar with him. So it's really, we lean into data-centric AI, where the differentiation has to be the data. So all this stuff, it's not the models. That's academia. Models in industry are basically solved to a certain extent. You have to have differentiated data. And so we can use that AI to create better models, or we can create more intelligent relevance measures to help our operators, or to do quicker or better computer vision algorithms, or fill in the gaps with our ghosting. So ghosting is nice as an application, but that's basically tracking. Where we have players missing, we can use our ghosting algorithm to impute where they're missing. So to answer your question, I think the moat is having the data, and you should never forget that. People who think, well, we have the models, they're not really defensible. So that's why it's great to work in a place like Stats Perform, because you have the data, and the future of data collection is human plus computer. It won't be fully automated, in my view, because to have the perception of a human, so we have 10 or 20,000 hours watching sport, so our human operators are very good at doing that. You can't expect that from a computer vision system. Even though we see the same pixels, we're not actually seeing the same pixels as a computer. Right? So I think you can draw parallels of what's happening in autonomous vehicles. I think Elon Musk summed this up very nicely, where he said driving systems are set up for human perception. So if you want to control it, if you look at robotics, that's very successful, where you can control the environment and set things up. For real-world situations, you really have to leverage the human perception there. And also leverage the inductive bias, because sport is a game of rules. You don't want to learn the rules directly from data. The rules there, can you inject that information into the system? And then you're going to be on your way to success there. Does that make sense?
Yeah.
Yeah.
So I have a question about this problem of having the data. So you said that tracking data is going to become more and more available, but I still don't have the sense how fast this will happen, because I see that most of the teams use still event data because of the problems you said. So let's assume that we can start having more availability of tracking data maybe in 3-4 years time, but in the meantime the teams have to use the data they have. Mm-hmm. So but they have limited resources, so maybe they have one person analyzing the data. So I have two questions about this. So in terms of strategy for this team, should they invest more on allocating the resources on developing better and more powerful model for tracking data that they may have currently limited availability, but potentially in 4 years time, 3 years time, when they will be ahead of everyone because they invested, because it takes more time to develop models for tracking data, or should they instead work right now with whatever they have, which is data, event data? That's one thing, because there are many teams like youth and women's teams for which we have no tracking data whatsoever, so they cannot think 4 years in the future. And the second question related to this is there any information we can learn from data where we have both and fill the gap of the event data?
So transfer learning. So excellent question. So the first answer I'll give to your first question is that you have to you have to look at the resources that the team has, and for a specific team, they may not have they're only focusing on their own performance, right? And so to do this, a lot of this stuff, you basically have to be a tech company, right? So it takes $1 million or $2 to actually build up the infrastructure. And it may not make sense for them to do it, right? So you have to look at, well, can we share resources? Can you use a company like Stats Perform or Zealous that Luke Bourne and Doug Fearing have set up, where they're basically providing a consultancy service? We know how to do it. Use our services, because you should focus on your own. Area of expertise, which is coaching and your players. You're not a tech company, and so I think a lot of teams err, especially if they only have one club and they try to be a tech company. I think that's throwing money away, because you need to have a lot of resources to do this effectively. However, if you're finding a trend now, football clubs, is that they own many clubs. Okay, if you look at the City Football Group, they own 5 or 6 clubs, or it's probably more. If you look at Boston Red Sox, I've lost track of who they own, but bits of Liverpool, so they can share those resources. I think you can see it across other businesses. If you look at private equity, we're owned by Vista. They own 80 different companies. So we can share those same resources around. So my answer to the first question, and if the team asks me, if you're doing it yourself, it's probably not a good use of your resources. And also, where is your competitive advantage? If we're doing it here, we capture public knowledge. We should generate solutions, and you should stand on the shoulders of what we do. And you raise a really good point for the second one, where you have private data. You could have academy data, or you could have physiological data. That's really where teams should have their focus, because there will never be solutions there. We will never get this private data. That's where they can have their competitive advantage. Also, I think you raised an interesting point around for the female game that's just growing in leaps and bounds. We should be able to leverage what we have here. A lot of it is male dominated. So we're the rights holder for WTA, so we have really nice solutions across those domains, but we should be able to do some transfer learning where they're not the same game. I'll use an example for tennis, like the serve in female tennis is not as dominant as male tennis, so we have to come up with different metrics. However, we can use that core data and adapt it using transfer learning, so we're not starting from scratch. So, did I answer both your questions? Yeah, does that make sense? Do you want to challenge that? I'd love to hear your thoughts.
No, I agree. It's just that I don't know, if especially lower level teams have the economical power to rely on.
Begs the question, so should lower tier teams should actually be doing this type of analysis? This is the 1%ers. And I think you just have to be very pragmatic. You think about coaches and experts, they're great machine learning. They have those classifiers there where they have known resources. I think when it gets to a point where, I heard this really good saying from the former head of Netflix engineering, we're at the age of information, we're in the age of recommendation. So when you have to make decisions where you're just swimming with data or long-term prediction tasks, how can you create assistive tools to help domain experts do their job better? The example around search and sport, if I'm required to spend 29 hours to find a play, can we do that better? If you haven't got the resources, you probably shouldn't be spending that amount of time to find a play. It's probably not that important. You can get the manager to simulate and reconstruct that. So I think in terms of resources, you just have to be pragmatic and just see the ROI. However, I do think a lot of the innovation coming up is going to be more around media and betting, because in terms of incentive for teams, there's no incentive. So just say you work for a team, they're not going to let you talk. They don't want to let any trade secrets out. And so that sharing really isn't there. And so I think for media embedding, where people at home, there's billions of people that love sport, they should have that same analysis as coaches and players do. I don't understand why they don't. And really, I see that's innovation, especially with OTT, streaming. We have streaming wars in the US. We have to create interactive tools to do that. And be interesting to see how broadcast is going, because there's a lot of money being spent out. Like if Apple, Amazon, Google start paying for broadcast rights, they have the platforms to do this. The metaverse is a big thing. The beautiful thing about sport is that it's one of the rare things that it's a shared experience. So I'm from Australia, I live in the US. I would like to watch a game with my dad, or watch a game of football or cricket with my dad. If we can do that simultaneously and we can have that interaction, that's powerful. And so I think, I didn't talk about it, but I'm really excited. I think sport is a beautiful thing. It's very positive, and it can really be a great thing, not for the pro space only, but for people at home. And so scaling and having these applications, I really see as a future, and not just helping teams make better decisions.